Okay, today we're going to talk about balancing chemical reactions. So the important idea with balancing chemical reactions is purely conceptual, and that is this. Whenever you have a change, in, say, compounds, or you could say appearance of a sample, matter cannot be created or destroyed. No surprise there, right? Conservation of mass. Matter cannot be created or destroyed. So if you start out with one material and then you do something to it and it becomes some other material, something has to happen that causes matter to be conserved, not created and not destroyed. Okay? So this is accomplished by the rearranging of atoms. And we'll do a little example here. Let's suppose that we're going to take hydrogen gas, and then we're also going to take some nitrogen gas. Okay, these are the formulas for nitrogen and hydrogen gas. They always hang around in groups of two atoms. Okay, and we're going to do a reaction with them and cause them to turn into ammonia. So we cannot just take one molecule of this and one molecule of that, because that would be like doing this. Look, here's the H. Here's the H's. Here's the N's. There's an N. Here's 3 H's. If we do that, we are not conserving mass, not conserving matter. We have 2 hydrogens here. We have 2 nitrogens here, but we don't have the same number here. We've gained an extra hydrogen. We've lost a nitrogen. You can't do that. It doesn't work because there are different numbers of protons in each and electrons and neutrons in each of these atoms. So you can't just change one into the other. You can't just say, oh, nitrogen, become a hydrogen. Oh, now we have the right number. You can't do that. Instead, you've got to have more of the one that you need more of. So you can look at this and you can just say, there's 2 hydrogens over here. There's 3 hydrogens over here. So I'm going to need some more hydrogens. Let's get another of those. You can't split it in half. They don't come in groups of 1. They only come in groups of 2. But now look, we've got a problem again. You've got 4 of these here and 3 of those here. So now we're going to have another ammonia. There you go. Uh-oh. Now we've got 1, 2, 3, 4, 5, 6 hydrogens and only 4 hydrogens over here. So we're going to add 1 more hydrogen over here. Now we've got 6 and 6. Let's check the nitrogens. Whenever you do this, you always want to start with just one element. Do one of the elements first and then switch and look at the other one and then come back and check the first one again. There's 2 nitrogens over here. Then we do our little chemical change and we have 2 nitrogens over here. So that checks out. So next thing then is to write the numbers. Here you go. There's 2 of these, right? There's 1, 2. There's 1 of those. You don't have to write it if it's a 1, unless you're doing it on Canvas, in which case you'll have to put the 1 in to make Canvas happy. And then there's 3 here. So there you go. You've got the whole thing. This is a balanced chemical reaction.